Hello. In this lecture, we will talk about VPN theory. We will start by talking about isakmp. Isakmp is the Internet Security Association and Key Management Protocol. It was put together to provide a framework for key exchange between two or more entities to negotiate encryption services. The isakmp defines something called security association. And the security association defines how the two entities are going to encrypt and hash traffic. There's two versions of IKE. There's IKE version 1 and IKE version 2. They both utilize isakmp for security association and management of crypto sessions in their framework. The Internet Key Exchange uses isakmp rules to establish the association between the peers. Encryption is the scrambling of a message in a way that if anybody stumbles on that message they would not be able to read it. That's the main concept of encryption. There are two types of encryption: symmetric encryption and asymmetric encryption. In the symmetric encryption, both sides use the same key to encrypt and decrypt. If you have two sides that are communicating to each other, let's say Alice and Bob, which is commonly used in encryption theories. Alice has a message to send to Bob. And this message, she wants to encrypt it or scramble it. She uses a key. And this key is already shared between Alice and Bob. So Alice has the key and Bob has the same key. She uses an encryption method. And this encryption method is called encryption algorithm. There are multiple algorithms out there like DES and AES. She would use one of those methods and encrypt this message using the key that was already shared with Bob. And then, she sends the encrypted message to Bob. When Bob gets the message, he decrypts the message using the same key that was shared with Alice ahead of time. And then Bob would be able to read the message. So, this is the concept of symmetric encryption. The key that is used in encrypting the message is the same key that decrypts the message between the sender and receiver. Terminology for encryption that you need to be familiar with. The encryption algorithm is referred to as cipher. And then, the outcome of the operation is referred to as ciphertext. Plaintext is the original message. Cipher is the algorithm. And then ciphertext is the outcome. In the case of asymmetric encryption, you have two keys that are mathematically related to each other. Key private and key public. So, Alice would have her own private key, and she would have a public key. That public key, Alice would share with anybody that wants to communicate with her. If she wants to communicate with Bob, Alice send her public key to Bob ahead of time. Bob also has a private key and a public key. And Bob would also share his public key with Alice. When Alice wants to communicate to Bob, she would encrypt the message using Bob's public key. And she would send that message to Bob. Then Bob gets the message from Alice. He would use his private key to decrypt the message. And if Bob wants to communicate with Alice or respond to Alice, he would use Alice's public key. He would send the response to Alice encrypted with Alice's public key. Alice would then be able to read that message, and only she can read it since she is the one that has the private key. So, the whole premise behind the asymmetric encryption is that what gets encrypted by the public key gets decrypted only by the private key. And this whole idea is behind the concept of certificates, and asymmetric encryption in general. Public keys get shared and are known to everybody. If I am sending you a message using your public key, nobody else can read it, except you. The holder of the private key is the only one that can read this message. Let's talk about hashing. Hashing is an irreversible operation that you can run on a message or packet. And this irreversible operation produces something called a hash, or signature or digest. And this is used for message authentication and integrity. The same concept of hashing is also used for something called pseudo-random function. And that's used in the IPsec protocol pretty heavily. So, the whole idea behind hashing is, if two parties want to talk to each other. If Alice wants to talk to Bob, and she has a message to send, she runs it through that hashing algorithm. She would run the message and produce something called a hash, or digest, or a signature. And then, she would prepare the message. She would append this hash to the message by adding it to the end of the message. Bob gets the message with the hash. If Bob wants to make sure that this message was not changed in transit, meaning that nobody transposed any character, or damaged the message or changed it in any way, Bob wants to verify that there's nothing missing from the message and it is indeed the actual original message. What Bob would do is extract the message, and run it through the same hash function which produces a hash. The hash received should be equal to the hash calculated. If the two sides are equal, if the two hashes are equal, then the message is confirmed to be the original message sent. If the two hashes are not equal, then the message was damaged or manipulated during transit. And this is the concept behind message authentication and message integrity. The hashing operation is used to verify that nothing changed. So, the two concepts of encryption and hashing combined are the two main foundation topics of IPsec. We will talk more in the next lecture.